Electrostatics of conductor. So today we are going to study about some properties of conductors. So first property is in static case the charge reside only on the surface of conductor. That is, the charges will be only on the surface of the conductor. No free charges are there inside the conductor. Inside the conductor there will be no free charges. So second point, the electric field intensity inside a conductor or cavity is zero. Electric field inside the conductor or a cavity is zero. And the third property is electric field lines are normal to the surface. Electric field lines are always normal to the surface of the conductor. And the fourth property is electrostatic potential is constant throughout the volume of conductor and it has same value on the surface. That is, inside the conductor, the electrostatic potential is constant throughout the volume. In the entire volume, the electrostatic potential is constant and on the surface also it is constant. So we have electric field inside the cavity or conductor is zero and we have E is equal to minus dV by dt. If E is equal to 0, 0 equal to dV by dt, which implies dV is equal to 0. That is, change in potential is equal to 0, which means there is no change in potential. That is, V is equal to constant. That is the fourth property. The electrostatic potential is constant throughout the volume of conductor and it has same value on the surface. Next we can study capacitance of a conductor. So capacitance is the capacity of a conductor to store charges. Capacitance is the capacity to store charges. For a conductor, the charge stored and its potential are directly proportional. That is, the charge stored, that is Q, is proportional to the potential. So we can remove the proportionality sign. Q is equal to C into V, where C is called capacitance of the conductor. So C is called the capacitance. C is called the capacitance. We can write C is equal to Q by V. So we can define C as the ratio of charge stored in the conductor to the rise in potential. C is the ratio of charge stored in the conductor, charge stored in the conductor to the rise in potential. So C is equal to Q by V. This is a very important equation and we can find the capacitance unit of capacitance as coulomb per volt or farad. F is farad. So next we can study the capacitance of a spherical conductor. So we have capacitance C is equal to Q by V, and for a spherical conductor we have potential V is equal to KQ by R. That is, we have capacitance is equal to Q divided by KQ divided by R, and the value of K is equal to 1 by 4 pi epsilon 0. So substituting that, we will get C is equal to 4 pi epsilon 0 R. So this is the capacitance of a spherical conductor, that is C is equal to 4 pi epsilon 0 into R. So write down this question. What is the capacitance of Earth? So we have the capacitance of a spherical conductor as C is equal to 4 pi epsilon 0 into R, and for Earth radius R is equal to 6,400 kilometer. So substituting these values, we know that 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. So 4 pi epsilon 0 will be 1 by 9 into 10 to the power 9, and radius R is equal to 6400 kilometers. So 10 to the power 3 meter, and the final answer will be 7.11 into 10 to the power minus 4 farad. Unit of capacitance is farad or coulomb per volt. So this is 711 microfarad.